Alright folks, today we're going to be looking at transformations, interpreting the vertex form, and these are just some examples. If you look back in your notes, hopefully you have your notebook at home, but of course we don't know if you do, so I'm going to go through this. Please look at the PDFs that I've included in the section above to help you remember all of the parent functions we've done. Alright, so this is an example of vertex form for a quadratic, and the plus or minus in front of the A is what indicates reflection. If it's negative, it reflects over the x-axis. The A is a stretch or a compress. If it's greater than 1, it stretches, it gets taller. If it's a fraction between 0 and 1, then it's a compression. H tells you whether to go to the right or left. Remember, x minus is standard, so if that minus sign becomes a plus sign, then you must have plugged in a negative number. K is your up and down. It can be positive or negative. Up is positive, down is negative. Let's look at a few examples. So the vertex form is helpful because H and K are our vertex. And in this case, it would be a positive 4 and a positive 2. Remember, x minus is standard. We plugged in a positive number. So how would we state the transformation? Well, it reflects over the x-axis. That's the negative. It stretches by a factor of 3. It moves right 4 units and up 2 units. That's how we would express it verbally. Now, this is a cube root function. That would be the parent function, goes through 0, 0. So what happens with this transformation? The only transformation is the negative. So that's the parent. And the pink one is the reflection over the x-axis. So there we go. Now we're multiplying by 3. Well, 3 is the A value. The A value will stretch or compress. Since it's greater than 1, it will stretch it. So that dotted line is, the parent. The pink one is taller. That's the way I would describe it. You got to choose an adjective that works for you, but it's higher. Alright, so now this is an absolute value function. The A, H, and K, fortunately, all do the same thing. The plus and minus in front do the same thing. The only difference is that it's a V shape. So what do we see? I start at the beginning. We have a positive 2. So the positive means there's no reflection. And I'm going to give you a chance to think about it. Is it going to go right? Well, the 2 does what? The 2 makes it thinner. The 4 moves it over to the right 4 units. And the 3 moves it up 3 units. So we have a stretch by a factor of 2. This is how we would say it. Right 4 units and up 3 units. That is a parent function for a square root function. Remember, it's only half of the U shape, right? And so there's the explanation in pink. X plus 3. Well, that is really x minus because that's standard. The plug-in number is a negative 3. So you can already see on my graph that I'm ready to go left 3 units. There is no reflection, and it's not going to be stretched or compressed. There's nothing in front of the square root. There's no A value, but 1. It's 1. All right, here's another example. So now I'm looking, and I see the 2. It's a positive 2, so there's no reflection. but it's going to be what? Stretched or compressed. If you're thinking stretched, you are correct. And of course, it then will be going back 3 units because you plugged in a negative number to make that a positive number. All right, and this is our last example for this page. Again, I have a positive 2. That's a stretch. No reflection. X minus 6. Well, that means I'm plugging in a positive 6, so it should be 6 to the right and up 1. And there it is. And that is a square root function. So remember, if you see a positive, you have to think, well, that's actually minus a negative number, which means I go to the left. It's kind of counterintuitive. And that, folks, is the end. You still are very awesome. And I hope you all have a great week. Thank you.